Mr. H here, and I have a physics riddle for you. Which of these three pucks is going to roll down the hill the fastest? One puck has a hole in the middle, one puck has holes on the edge, and a third puck was left alone as is.
Well, I'm gonna have to protect that. This is gonna go first, second, and third.
First place, second place has a hole in it in the middle, and third place, two holes on the outside. Why did you pick that order? Why did you pick this one first? Heaviest?
Yeah, it seems like the heaviest has no holes.
So you went in order of weight?
Yes.
Okay.
So I was drawn to this one being the winner of the race because I ride bicycles and the light rim on a wheel is said to make it accelerate faster. And so I thought this one would pick up speed faster than the rest. I don't know that there's any difference between these two. So I'll go first, second, third.
Like it's gonna have like sharp periods of going down and stopping. So I think that's gonna make it slower. So
that's last?
last.
They're all gonna go at the exact same speed because as long as you're not, because it's the same weight no matter what. So.
Okay.
I'm trying to think how holes can affect them. So, does this have to do with anything like weight displacement?
Now, before we solve this problem, let's take a look back at a similar problem from centuries ago. The question of which will fall faster, a heavy object or a light object, has plagued mankind for centuries. It was long believed that heavier objects, due to their weight, would win this race. It was eventually proven by Galileo that heavy objects and light objects drop with the same rate of acceleration due to gravity. This result can be explained through Newton's second law of motion, F net equals ma, where the larger mass gets a larger weight term, mg, but it also has a larger inertia term in the ma. So what ends up happening is the m's cancel out and you just have a equal to g. Now what's often overlooked is that these two m's have different meanings. The m in ma has to do with inertia. The m in mg has to do with an object's gravity. Newton's second law for rotation works very similarly in that we have a net torque which equals an inertia term times an acceleration term. So it might be tempting to think that all three of these will roll down at the same rate for the same reason. However, this inertia term is affected by the location of those holes. How might those holes affect the rotational inertia, I wonder? To conceptualize this effect, let's pretend the puck is a merry-go-round and we will put people on the edge of it. To set this merry-go-round in motion will take a lot of force because there's a lot of inertia on the edge that's going to be hard to accelerate around. Similarly, if all of the objects were at the center, they would be easy to rotate. So arrangements 1 and 2, even though they have the same amount of mass, they have different values for rotational inertia. 2 is easier to spin because the mass is more concentrated at the center. Now let's take a look at those pucks again. The one that had a hole in the center, we took away the stuff that was easiest to twist. By subtraction, the rest of it is on average harder to twist. Now the puck that had the holes on the edge, we took away mass that was difficult to twist, making its higher concentration of mass in the center, which is easy to twist.
With the one hole.
Who's going to win first place? Who's going to be second place?
This one.
Second place?
Animals, get set, go.
I would think it would be the fastest. This one. 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 This
knows what's up. It's the only person I've ever asked that question to get it right.
Hope you enjoyed this video, and in the future, if you have to deal with any rotating down incline type things, just remember how easy things are to twist have to do with their mass distribution, and these coefficients for moments of inertia can really help you out. The lower coefficient is going to be easier to twist, the higher coefficient harder to twist. Good luck.